Welcome to Surds Level 6, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move on to a different topic, and you can find topic by topic playlists on the channel homepage. In problem 1, we're trying to show that this expression is an integer. Now this is quite a complex expression, so what I'm going to do is I'm going to look at each of the two fractions separately. I'm going to rationalise and simplify each one and then subtract afterwards. Now looking at the numerator on the first fraction, we have 2 root 5 plus 3 squared. And this means that 2 root 5 plus 3 is being multiplied by itself. So we can write it out in two separate brackets. And we can now expand. And if you'd like a bit more help with expanding brackets in general, take a look in the top right corner where you can see my course on expanding brackets. Now back to the problem. So we're going to start by multiplying together 2 root 5 and 2 root 5. Well, 2 times 2 is 4, and root 5 times root 5 is just 5. So we have 4 times 5. 2 root 5 multiplied by 3 becomes plus 6 root 5. 3 times 2 root 5 becomes again plus 6 root 5. And 3 multiplied by 3 gives us plus 9. And we can now simplify this because 4 times 5 is 20. We can collect together the plus 6 root 5 and the plus 6 root 5 to give us plus 12 root 5. And we still have a plus 9 on the end. And we can finish simplifying by collecting together the 20 and the plus 9. So we have 29 plus 12 root 5. And this is the numerator of the first fraction. So the first fraction now becomes 29 plus 12 root 5, all divided by root 5 minus 2. Now, we can't simplify the numerator or the denominator anymore as they are, but we can rationalise. And we can rationalise this by multiplying the top and bottom by the conjugate of the denominator. And the conjugate of root 5 minus 2 is root 5 plus 2. So we're going to multiply both the top and bottom by that, making sure that we put everything in brackets for when we expand. So focusing now on the numerator, we can expand. 29 multiplied by root 5 is just 29 root 5. 29 multiplied by 2 gives us plus 58. 12 root 5 times 5 becomes plus 12 times, and root 5 times root 5 is 5. And finally, 12 root 5 multiplied by 2 is plus 24 root 5. Similarly, we can expand on the denominator. So we have root 5 multiplied by root 5, which is 5. Root 5 multiplied by 2 is plus 2 root 5. Minus 2 multiplied by root 5 is minus 2 root 5. And minus 2 multiplied by 2 is minus 4. And we now just need to simplify this. So looking at the numerator, we know that we have 29 root 5, and we can add to that 24 root 5. And this gives us 53 root 5. We also have 12 times 5, which is 60. And if we add that 60 to the 58, we have 118. So we have a plus 118. On the denominator, as we expect when we rationalise, the 2 root 5 and the minus 2 root 5 cancel out. We have 5 minus 4, which is 1. And when we divide by 1, the numerator just stays the same. So this becomes 53 root 5 plus 118. And so this is what our first fraction is equivalent to. We can now move on to the second fraction. And the numerator of a second fraction can't be simplified as it is, so we can just go straight into rationalising. And this means that we can multiply the top and bottom by the conjugate of the denominator. And to get that, we write the denominator out again, but we just change the sign in the middle, so from a plus to a minus. And we do exactly the same on the numerator, and we make sure that everything is in brackets so that we can expand accurately. So starting on the numerator, we have 636 multiplied by 2 root 5. Well, 636 times 2 is 1272. This becomes 1272 root 5. Next, 636 times minus 1 is minus 636. 265 root 5 multiplied by 2 root 5 gives us, well, 265 multiplied by 2 gives us plus 530. And root 5 times root 5 gives us 5. So we get 530 times 5. Finally, we have 265 root 5 multiplied by minus 1, which is minus 265 root 5. Moving our attention to the denominator, we can start by multiplying together 2 root 5 and 2 root 5. Well, 2 times 2 is 4, and root 5 times root 5 is just 5. 2 root 5 multiplied by minus 1 is minus 2 root 5. 1 times 2 root 5 is plus 2 root 5. And 1 multiplied by minus 1 gives us minus 1. And we can now simplify. So starting with 1272 root 5 minus 265 root 5, this gives us 1007 root 5. We have a minus 636, and 530 multiplied by 5 gives us plus 2650. On the denominator, again, our minus 2 root 5 and plus 2 root 5 cancel out, and we have 4 times 5 minus 1. So 4 times 5 is 20, so we get 20 minus 1. Now, staying with the numerator, we can simplify this. So we have 1007 root 5, and minus 636 plus 2650 gives us plus 2014. And on our denominator, 20 minus 1 gives us 19. Now we can check to see whether 1007 and 2014 are multiples of 19, and they actually are. And what this means is that we can simplify the numerator further. So 1007 divided by 19 gives us 53. So this becomes 53 root 5, and 2014 divided by 19 gives us plus 106. So our second fraction is equivalent to 53 root 5 plus 106. All that's left to do now is to take what was the first fraction, and we've now written as 53 root 5 plus 118, and subtract from that the second fraction, which we now know we can write as 53 root 5 plus 106. Now, because we're subtracting and we've got two terms here that we're subtracting, we need to make sure that we put this in a bracket so that we show that we're subtracting everything there. Now, having a minus in front of a bracket is equivalent to having a minus 1 in front of it, and we can use this to expand the bracket. So we have 53 root 5 plus 118, and then minus 1 times 53 root 5 is minus 53 root 5, and minus 1 times 106 is minus 106. If we simplify now, we can see that the 53 root 5 and the minus 53 root 5 just become 0 or cancel out. So we're left with 118 minus 106, and this gives us 12. So our final answer to problem 1 is an integer as we were expecting, and that integer is 12. In problem 2, we're given a right angled triangle where the base is root 3 plus 1 centimeters and the perpendicular height is 8 centimeters. We're told that the area is 9 plus 3 root 3 centimeters squared, and we need to show that x, the perpendicular height, is 6 root 3. So to start here, I'm going to write down my formula for the area of a triangle. And to find the area of any triangle, we can just do half times the base times the perpendicular height. I'm going to substitute in here what we know from the question. So we know the area on the left-hand side, that's 9 plus 3 root 3. That's going to be equal to a half multiplied by the base, and the base is root 3 plus 1, and times the height, and the height is x. That's what we need to know. So what we need to do now is solve this equation. So the first thing I'm going to do is remove the times a half from the right-hand side, because that's slightly annoying. So we can remove a times a half by either dividing by a half, or equivalent to that, we can just multiply by 2. So that's what I'm going to do. So if we times the right-hand side by 2, we need to make sure that we times everything on the left by 2. When you multiply, you have to multiply every term in the equation. So on the left, we have 9 times 2, which gives us 18. 3 root 3 multiplied by 2 is plus 6 root 3. And that's equal to, and our half has disappeared, so we just have root 3 plus 1 x. Now to get the x on its own, we need to divide by root 3 plus 1. So we can do this on the right-hand side, and we can do exactly the same thing on the left. And dividing the whole of the left side by root 3 plus 1 is just the same as dividing each of the individual terms. So I could also do that. But it's going to be a bit easier just to write this as 18 plus 6 root 3 all divided by root 3 plus 1. And on the right hand side we have x. So we have actually found the value of x, but we don't have it in the form that they want us to have it in the question. We want to write this as 6 root 3. And what we notice about the form of the answer that's given in the question is that it's not a fraction and it's not something that needs to be rationalized, whereas what we have can be rationalized. So that's a really good starting point. So to rationalize this expression, we need to multiply the top and bottom of the fraction by the conjugate of root 3 plus 1, which is root 3 minus 1. We need to make sure that this goes in brackets and that we do it to both the top and the bottom. So starting with the numerator, we can expand. So we have 18 multiplied by root 3, which is 18 root 3. 18 multiplied by minus 1 is minus 18. Next, 6 root 3 multiplied by root 3 gives us plus 6, and root 3 times root 3 is 3, so we get plus 6 times 3. And finally, 6 root 3 multiplied by minus 1 is minus 6 root 3. We're also going to expand on the denominator. So we have root 3 times root 3, which is just 3. Root 3 times minus 1 is minus 1 root 3, or just minus root 3. Next, we have 1 times root 3, which is plus root 3. And finally, 1 times minus 1 is minus 1. Going back to our numerator, we can simplify. So we can collect together 18 root 3 and minus 6 root 3. And 18 minus 6 is 12, so this gives us 12 root 3. We have minus 18 plus 6 times 3, which is 18. On the denominator, the minus root 3 and the plus root 3 cancel out, so we're just left with 3 minus 1, which is 2. Looking at the numerator, we have 12 root 3, but the minus 18 and the plus 18 cancel out, or when we collect them together, they just become 0. So our numerator just becomes 12 root 3, and we have a divide by 2 at the bottom. And because 12 divided by 2 is 6, 12 root 3 divided by 2 gives us 6 root 3. And that's exactly what we're asked to get to in the question. So that's the end of problem 2. In problem 3, we're asked to show that this expression can be expressed in the form a root 2 plus b, where a and b are constants to be found. Now to start, and before I add the two fractions together, I'm going to rationalise each one because we have surds in the denominator, and this will hopefully make the adding process a little bit easier. So starting with the first fraction, we have 2 over root 2 plus 1. And to rationalise this, we need to multiply the top and bottom of the fraction by the conjugate of the denominator. And the conjugate is just the same denominator we had before, but with a different sign in the middle. So we have root 2 minus 1. I'm going to put brackets around these so that I can multiply accurately. So starting with the numerator, we're going to expand. So we have 2 times root 2, which gives us 2 root 2. And then 2 times minus 1 is minus 2. On the denominator, we can expand by multiplying root 2 by root 2 first. This gives us 2. Root 2 multiplied by minus 1 is minus root 2. 1 multiplied by root 2 is plus root 2. And 1 multiplied by minus 1 is minus 1. Now the numerator can't be simplified anymore at the moment, so this just stays as 2 root 2 minus 2, but our denominator can, because as expected, the minus root 2 and the plus root 2 cancel each other out, so we're left with 2 minus 1, which just gives us 1. Now dividing 2 root 2 minus 2 by 1 just keeps it the same. So 2 root 2 minus 2 is equivalent to our first fraction. Moving on to our second fraction, we have 3 over 2 root 2 minus 1, and we're going to do this in a very similar way. So we're going to multiply the top and bottom of this fraction by the conjugate of 2 root 2 minus 1, which is 2 root 2 plus 1. Put each of these into a bracket, expand and simplify. So starting on the numerator, we have 3 times 2 root 2, which is 6 root 2, and 3 times 1, which gives us plus 3. In the denominator, we have 2 root 2 times 2 root 2. Well, 2 times 2 is 4, and root 2 times root 2 is 2. So we get 4 times 2. Next, 2 root 2 times 1 is just 2 root 2. Minus 1 times 2 root 2 is minus 2 root 2. And finally, minus 1 times 1 gives us minus 1. Now the numerator here can't be simplified at the moment, so we just have 6 root 2 plus 3, but the denominator can be simplified because again, the 2 root 2 and the minus 2 root 2 are going to cancel out. And this leaves us with 4 times 2, which is 8, minus 1, which is 7. Now, because neither 6 nor 3 share any common factors greater than 1 with 7, we can't simplify this fraction anymore. So 6 root 2 plus 3 over 7 is equivalent to our second fraction. So our original expression becomes 2 root 2 minus 2, which we're substituting for our first fraction, plus 6 root 2 plus 3 over 7, which is substituting for our second fraction. Now there are a few different ways of collecting these two together. The method I'm going to use is to think of the 2 root 2 minus 2 as being over 1, making common denominators and then collecting everything together. So to make these two have the same denominator, we can just multiply the first fraction on the top and the bottom by 7. So this becomes 7 times 2 root 2 minus 2 all over 7 plus 6 root 2 plus 3 over 7. And now that the denominators are the same, we can just add the numerators together. So I'm going to add the numerators together at the same time as expanding that first bracket. So looking at the numerator, we have 7 times 2 root 2 is 14 root 2, and 7 times minus 2 is minus 14. And from the second fraction, we have plus 6 root 2 plus 3, and this is all over 7. And we can now simplify that numerator. So on the numerator, we have 14 root 2 plus 6 root 2, which gives us 20 root 2. And we also have a minus 14 plus 3. And minus 14 plus 3 gives us minus 11. And this is still all over 7. Now this is actually simplified, but to get it into the required form, we need to split the 7 amongst the two terms in the numerator. So starting with 20 root 2, 20 root 2 divided by 7 can just be written as 20 over 7 root 2. And minus 11 divided by 7 can just be written as minus 11 over 7. And it's now in the required form where a is 20 over 7 and b is minus 11 over 7. So 20 over 7 root 2 minus 11 over 7 is our final answer to problem 3.